Imagine weapons that travel at 15,000 miles per hour, invisible aircraft that rewrite air superiority, and soldiers with superhuman capabilities. This isn't science fiction, it's America's military reality. Today on Sci&Y, we're unveiling 10 groundbreaking innovations that are reshaping modern warfare. From hypersonic missiles that can strike anywhere on Earth in minutes to quantum computers that crack enemy codes instantly, these technologies represent the most significant military leap since the atomic age. Prepare to witness the future of American defense dominance. Hypersonic weapons. A missile traveling at Mach 20 can cross an entire continent in under 30 minutes, making every defense system on Earth obsolete. The US military's Dark Eagle hypersonic weapon system represents a quantum leap in strike capability. Officially known as the Long Range Hypersonic Weapon, or LRHW, this boost glide system launches a common hypersonic glide body that separates from its rocket booster and glides toward targets at speeds exceeding Mach 5. The Army successfully tested the complete system in December 2024, marking a critical milestone in America's hypersonic arsenal. Each Dark Eagle battery consists of 4 transporter erector launchers, mounted on modified trucks, each carrying 2 missile canisters. What makes these weapons revolutionary isn't just their incredible speed, it's their unpredictable flight path. Unlike ballistic missiles that follow predictable arcs, hypersonic glide vehicles can maneuver during flight, making interception nearly impossible. The Navy plans to deploy ship-launched variants on Zumwalt-class destroyers by 2025, while the Army aims for full operational capability across multiple batteries. With a range exceeding 1,700 miles and the ability to carry conventional warheads, Dark Eagle transforms America's ability to strike high-value targets anywhere in the world within minutes of launch authorization. Directed energy weapons. The U.S. Navy's laser weapon system can silently destroy incoming missiles, boats, and aircraft, all while remaining completely invisible to the naked eye. Directed energy weapons have transitioned from science fiction to battlefield reality, with the U.S. military leading global development. The Navy's Laser Weapon System, or LAWS, represents the first operational deployment, successfully installed aboard USS Ponce in 2014 as a 30-kilowatt solid-state laser. This invisible weapon can detonate explosives, disable boat engines, and shoot down small aircraft with pinpoint accuracy. The Air Force's Tactical High-Power Operational Responder, or THOR, takes a different approach, using high-power microwaves to disable drone swarms and electronic systems. What makes directed energy weapons game-changing is their virtually unlimited ammunition. As long as there's electrical power, they can continue firing. Each shot costs mere dollars compared to traditional missiles costing millions. The Pentagon has allocated nearly $30 billion over the next decade for directed energy development, with systems planned for land vehicles, ships, and aircraft. Current limitations include power requirements and atmospheric interference, but advances in compact fusion reactors and adaptive optics are rapidly solving these challenges. By 2030, directed energy weapons will likely defend against hypersonic missiles, satellite attacks, and massive drone swarms, providing America with an impenetrable energy shield. Autonomous combat vehicles. Unmanned combat vehicles can now operate for 35 miles per hour across hostile terrain, carrying 1,000-pound payloads while making life-or-death decisions without human intervention. The U.S. Army's Robotic Combat Vehicle program is creating the world's first truly autonomous ground combat force. Despite recent program reassessments due to drone vulnerability concerns, companies like Overland AI have demonstrated remarkable capabilities with their Ultra Vehicle system. During 2025 testing, soldiers controlled these autonomous platforms through 15 live mission scenarios, including kinetic warfare, electronic attacks, and payload deployment. The vehicles successfully navigated complex terrain without GPS, adapted to changing battlefield conditions, and coordinated multi-vehicle operations in real time. 4 prototype systems from major defense contractors, including Textron's Ripsaw, General Dynamics TRX, and Oshkosh's RCV, have undergone extensive evaluation. These platforms can transport supplies, conduct reconnaissance, and engage targets while keeping human soldiers out of harm's way. The modular design allows rapid reconfiguration for different missions, from counter-drone defense to logistics support in contested zones. While the Army continues evaluating cost-effectiveness against drone threats, the underlying technology demonstrates unprecedented autonomous capabilities. Future iterations will likely integrate swarm intelligence, allowing multiple vehicles to coordinate attacks, share intelligence, and adapt tactics dynamically, creating an unstoppable robotic ground force. Advanced cyber warfare capabilities. The digital battlefield. Advanced cyber warfare capabilities mean America's cyber warriors can infiltrate enemy networks, disable critical infrastructure, and manipulate information systems, all from thousands of miles away, and honestly, without ever firing a single shot. U.S. Cyber Command has evolved into the world's most sophisticated digital warfare organization, commanding 133 cyber mission force teams across all military branches. These elite units conduct hunt-forward operations, proactively seeking threats in allied networks, defending U.S. elections from foreign interference, and launching offensive operations against adversaries. The 2021 International Institute for Strategic Studies ranked the United States as the world's foremost cyber superpower, combining unmatched offensive, defensive, and intelligence capabilities. Cyber National Mission Force teams specialize in defending the nation by detecting adversary activity, blocking attacks, and conducting counter-operations in real time. Recent operations include supporting Ukraine's cyber defenses against Russian attacks and neutralizing Iranian hackers in Albania. The challenge lies in force readiness. Many teams operate at only 67 to 75% capacity due to personnel shortages and the complexity of cyber operations. However, ongoing investments in quantum-resistant encryption, AI-enhanced threat detection, and automated response systems are, frankly, revolutionizing cyber warfare capabilities. Future cyber operations will integrate with space-based assets, hypersonic delivery systems, and autonomous platforms, creating a seamless digital physical warfare environment where America can disable enemy capabilities before kinetic weapons are ever deployed. Next-generation stealth aircraft, the Invisible Air Force. Next-generation stealth aircraft are changing the game. The U.S. Air Force has already flown a sixth-generation fighter that, well, breaks every record in aviation history, and China has no idea what hit them. America's Next-Generation Air Dominance, or NGAD program, achieved a historic milestone in 2020 when the Air Force flew its sixth-generation fighter prototype, years ahead of any competitor. The F-47, as it's becoming known, represents a revolutionary leap beyond traditional fighter concepts. This tailless, highly stealthy aircraft features adaptive engines producing 35 to 40,000 pounds of thrust, enabling sustained speeds above Mach 2, with operational ranges exceeding 1,500 miles. The aircraft will operate in both manned and unmanned configurations, serving as the central brain for collaborative combat aircraft drone swarms. Advanced AI systems enable real-time coordination with multiple unmanned platforms, creating an integrated air dominance network. The B-21 Raider bomber complements this capability, offering next-generation stealth at $692 million per aircraft, significantly cheaper than the $2 billion B-2 Spirit. With its optionally manned design and ability to carry both nuclear and conventional weapons, the B-21 provides strategic reach across the Pacific. 3 B-21s are currently in flight testing with operational deployment planned for 2027. These platforms will integrate directed energy weapons, hypersonic missiles, and AI-enhanced sensors, creating an invisible, unstoppable air force that can strike anywhere while remaining undetected. Soldier Augmentation Systems, the Enhanced Warrior. Soldier augmentation systems are here, and U.S. soldiers now wear augmented reality headsets that let them see through walls, around corners, and through smoke, while coordinating with AI-powered battlefield networks in real time. The Army's Integrated Visual Augmentation System, or IVAS, transforms individual soldiers into enhanced warriors with honestly superhuman capabilities. Built on Microsoft HoloLens technology, IVAS provides thermal and low-light vision, rapid target acquisition, aided target identification, and augmented reality overlays directly in the soldier's field of view. During 2024 testing with the 82nd Airborne Division, soldiers accumulated over 40,000 hours of operational data across company-sized training events. The ruggedized system withstands combat conditions while providing real-time mapping, mission planning, and after-action review capabilities. Soldiers can rehearse operations in virtual environments, coordinate with team members through digital displays, and access critical information without taking their eyes off the battlefield. The Fight Rehearse Train system allows unlimited scenario practice anywhere, anytime. Beyond visual augmentation, military research explores exoskeletons for enhanced strength and endurance, biometric monitoring for health optimization, and neural interfaces for seamless human-machine integration. Future soldier systems will integrate with autonomous vehicles, drone swarms, and cyber warfare platforms, creating a networked warrior capable of dominating any battlefield environment. These enhanced soldiers represent the evolution of human combat capability, where technology amplifies natural abilities to superhuman levels. Quantum computing for defense. Well, it's kind of a game changer. Quantum computers can crack encryption codes that would take traditional computers billions of years to solve, completing the task in mere minutes. The Pentagon's quantum computing initiative represents the most significant advancement in military computation since the digital revolution. With over $100 million committed to quantum technologies, the Department of Defense is developing applications in three critical areas: quantum sensing, quantum computing, and quantum communications. DARPA's Robust Quantum Sensors Program, or ROQS, creates military-grade sensors that maintain performance under harsh battlefield conditions, enabling detection of submarines, nuclear materials, and concealed threats with, honestly, unprecedented precision. Quantum computers will revolutionize military logistics by optimizing complex supply chains, analyzing vast intelligence datasets, and solving previously impossible strategic problems. The Air Force allocated $2.5 million to develop quantum software for military logistics optimization, while the National Quantum Initiative provides $3 billion in federal funding for quantum research. The technology's most concerning application involves breaking current encryption systems. Quantum computers could potentially crack the codes protecting military communications and classified data. To counter this threat, the Pentagon is implementing post-quantum cryptographic infrastructure, ensuring data security in the quantum era. Future quantum applications include quantum radar systems immune to stealth technology, quantum communication networks impossible to intercept, and quantum-enhanced artificial intelligence systems that process battlefield information at unprecedented speeds. Drone swarm technology, the autonomous Air Force. Drone swarm technology is, honestly, changing the game. The Pentagon's Replicator program is set to deploy thousands of autonomous drones that can coordinate attacks, share intelligence, and adapt tactics, all without human control. America's drone swarm technology has evolved from experimental concepts to operational reality, with the Pentagon's Replicator program leading global development. The $500 million initiative aims to deploy thousands of inexpensive autonomous drones by August 2025, focusing on autonomous collaborative teaming and resilient network communication systems. The PERDIC system, operational since 2016 and developed by MIT Lincoln Laboratory, has produced over 670 drones capable of coordinating with F/A-18 fighter jets in complex swarm operations. These systems demonstrate unprecedented collective intelligence, where individual drones communicate in real time to navigate GPS jamming, radio interference, and adverse conditions while still maintaining synchronized operations. Recent testing shows swarms can overwhelm traditional defense systems through sheer numbers and coordinated tactics. The Swedish Armed Forces unveiled software that controls up to 100 drones simultaneously, while US forces tested swarms across 15 live mission scenarios, including reconnaissance, electronic warfare, and payload delivery. The technology's military advantage really lies in cost-effectiveness. Swarms of expendable drones provide affordable alternatives to million-dollar missiles while offering superior flexibility and resilience. Looking ahead, future swarm applications include autonomous logistics, perimeter defense, and coordinated strikes against high-value targets, creating an unstoppable aerial force that adapts and evolves in real time. Space-based weapons, the ultimate high ground. Space-based weapons are, well, ushering in a whole new era. The US Space Force is developing 6 different types of space weapons, including anti-satellite systems and orbital interceptors that can strike targets anywhere on Earth. America's space warfare capabilities represent the ultimate military high ground, with the Space Force developing comprehensive orbital weapon systems. Current acknowledged capabilities include ground-based communications jammers that interfere with satellite signals, but classified programs likely extend far beyond public knowledge. The Golden Dome Missile Defense Initiative includes space-based interceptors designed to counter ballistic missiles and potentially hostile satellites during conflict. Advanced robotic systems demonstrate satellite capture and manipulation capabilities, with companies like Maxar and Northrop Grumman developing arms capable of engaging non-cooperative satellites in orbit. The Air Force Research Laboratory's Starfire range utilizes sodium guide stars for precise satellite tracking and imaging, while directed energy weapons in space could disable spacecraft through laser or microwave attacks. Space-based kinetic weapons remain theoretical but technically feasible, offering global strike capabilities with minimal warning time. The challenge lies in international treaties prohibiting weapons of mass destruction in space, though conventional weapons face fewer restrictions. Future space weapons will likely integrate with hypersonic delivery systems, quantum communication networks, and AI-controlled platforms, creating an orbital defense network capable of protecting American interests while projecting power globally. Control of space increasingly determines terrestrial military dominance. AI-powered command systems, the digital general. AI-powered command systems honestly are changing how wars are fought. Artificial intelligence systems can now process battlefield intelligence, coordinate multi-domain operations, and make strategic decisions faster than any human commander, revolutionizing military leadership itself. The U.S. military's artificial intelligence revolution extends beyond individual weapons to comprehensive command and control systems that process information and coordinate operations at superhuman speeds. AI-enhanced sensors provide real-time battlefield awareness, analyzing satellite imagery, drone feeds, and electronic intelligence simultaneously to create comprehensive operational pictures. Machine learning algorithms predict enemy movements, optimize resource allocation, and recommend tactical adjustments based on evolving conditions. The integration of AI with existing military systems creates force multipliers, where human commanders leverage artificial intelligence to manage complex multi-domain operations spanning land, sea, air, space, and cyberspace simultaneously. Advanced AI systems coordinate between hypersonic weapons, drone swarms, cyber operations, and space-based assets to execute synchronized campaigns impossible for human planners alone. Natural language processing enables seamless communication between AI systems and human operators, while predictive analytics anticipate logistical needs and maintenance requirements before problems occur. Future AI command systems will integrate quantum computing power, enabling real-time analysis of massive datasets and strategic planning across multiple scenarios simultaneously. These digital generals don't replace human judgment but amplify it exponentially, creating military decision-making capabilities that process information, coordinate responses, and adapt strategies at the speed of light. From hypersonic missiles that, honestly, redefine global strike capability to AI systems that think faster than human commanders, these 10 innovations represent America's technological dominance on tomorrow's battlefield. Each system doesn't just enhance existing capabilities, it fundamentally transforms how warfare is conducted. If you're fascinated by these game-changing technologies and want to explore more cutting-edge military innovations, hit that like button, share your thoughts in the comments, and subscribe to Sci&Y for more deep dives into the technologies shaping our world. Thanks for watching, stay curious. When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Sci&Y, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shock waves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The heliopause's shocking behavior. The boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation? Electronic confusion in the cosmic deep. So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270°F environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon, unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured. The cosmic radiation bombardment. Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, wow, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration. Software updates across the cosmic void. NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space. Revolutionary discoveries that changed everything. Voyager 1's journey revealed that Jupiter has 3 delicate rings. Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail. The eternal journey into galactic immortality. In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos. After 46 years of traveling through space, Voyager 1 finally sent back data from beyond our solar system that nobody saw coming. This isn't just another space mission update, it's a complete game-changer for everything we thought we knew about the universe. The tiny spacecraft has crossed into interstellar space and discovered an environment so strange and structured that scientists are, honestly, rewriting their textbooks. Get ready to have your mind blown by what's really lurking in the darkness between stars, because the truth is absolutely incredible. The Great Silence and Revival. Space exploration hit a terrifying moment in late 2023 when humanity's most distant messenger went completely silent. Voyager 1, our faithful explorer that had been sending data for nearly 5 decades, suddenly started transmitting nothing but garbled, meaningless signals. Engineers at NASA faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away. The culprit was a corrupted memory chip, likely destroyed by the same cosmic rays Voyager was studying. The fix required rerouting decades-old code into backup systems while dealing with a 22-hour communication delay. By April 2024, the impossible happened. Voyager came back to life, and what it began transmitting would change our understanding of space forever. The magnetic revelation. Something extraordinary happened when Voyager's magnetometer came back online. It revealed that space between stars operates by completely different rules. The spacecraft detected an interstellar magnetic field that's dramatically misaligned with our sun's magnetic influence, suggesting Voyager has encountered a galactic-scale boundary zone. These aren't minor variations. They're fundamental structural differences that point to magnetic turbulence zones where galactic fields twist and reconnect in ways scientists never predicted. The readings indicate Voyager might be navigating through invisible cosmic highways where magnetic forces create pathways and barriers throughout our galaxy. This discovery means the Milky Way has an underlying magnetic skeleton that influences everything from star formation to the flow of cosmic material, and we're only now getting our first direct measurements of this hidden architecture. The Cosmic Storm. The moment Voyager 1 crossed the heliopause in 2012, it encountered a radiation environment so intense it would be lethal to any human traveler. High-energy cosmic rays, accelerated to nearly light speed by distant supernovae and black holes, bombard the spacecraft at rates dramatically higher than anything measured inside our solar system. The jump wasn't gradual, it was like stepping through an invisible force field into a cosmic shooting gallery. These measurements reveal that our sun's protective bubble shields Earth far more effectively than anyone realized, creating a cosmic oasis in what's essentially a galaxy-wide radiation storm. The pattern of these particles isn't random either. Voyager has detected systematic variations suggesting natural radiation corridors that could represent the aftermath of ancient stellar explosions that shaped our galactic neighborhood millions of years ago. The Whispering Void. Forget everything you've heard about the silence of space. Voyager 1 has discovered that interstellar space is actually humming with constant activity. The spacecraft's plasma wave instrument detects persistent low-frequency oscillations that create a cosmic soundtrack most people will never hear. These aren't just random noise. They're organized pressure waves moving through space like invisible weather fronts. Multiple density spikes indicate Voyager is encountering shock fronts left behind by ancient supernovae that exploded thousands of years ago, with their energy still rippling through the cosmic medium. The most fascinating discovery is how layered this environment appears to be. Some regions are hotter, others denser, creating distinct climate zones in what we assumed was uniform emptiness. This cosmic weather system suggests interstellar space has its own complex meteorology. Mapping the invisible galaxy. Every data packet Voyager 1 transmits is helping scientists construct something unprecedented, a three-dimensional navigation map of interstellar space. The The spacecraft has become humanity's anchor point for understanding the Milky Way's invisible infrastructure, measuring cosmic ray gradients, particle densities, and magnetic field orientations that reveal the hidden structure of our galactic neighborhood. This isn't theoretical modeling anymore, it's real-world cartography of the cosmos, like having a weather satellite for space between stars. The radiation mapping has profound implications for future human space exploration, as the intensity of interstellar radiation is far more dangerous than what astronauts encounter in Earth orbit. Understanding where natural shields and danger zones exist could determine whether humans can ever safely venture beyond our solar system, making Voyager's measurements crucial for planning humanity's next giant leap into deep space. The Cloudlet Highway. Since entering interstellar space, Voyager 1 has passed through at least 2 distinct interstellar cloudlets, regions where plasma, dust, and gas density suddenly changes by factors of 2 to 3 times. These discoveries reveal that the space between stars resembles an ocean with currents, eddies, and weather patterns, rather than the uniform void astronomers once imagined. The probe's instruments show evidence of structured plasma ripples with clear boundaries and characteristics, suggesting large-scale organization in what scientists thought was chaos. NASA researchers now believe our sun is moving through the local interstellar cloud, with Voyager helping define its outer edges inside the much larger local bubble, an enormous cavity created by ancient supernovae explosions. These density shifts could affect Earth's exposure to cosmic radiation over millennia, as our solar system drifts through different interstellar environments, potentially influencing everything from cloud formation to biological mutation rates. The Galactic Boundary Zone. So, the transition from our solar system to interstellar space turned out to be, well, far messier and more complex than anyone predicted. Voyager 1 revealed that crossing the heliopause isn't like passing through a clean boundary. It's more like navigating a chaotic swirl of plasma, radiation, and magnetic forces that shift and change as our sun moves through the galaxy at 450,000 miles per hour. The boundaries Voyager crosses aren't fixed structures but dynamic zones that evolve constantly. Magnetic fields don't align as expected, radiation environments change dramatically over short distances, and plasma waves suggest ongoing activity that scientists are only beginning to understand. This complex interstellar weather creates an environment where the edge of our solar system becomes less of an edge and more of a turbulent frontier zone, where solar and galactic influences battle for dominance in an invisible cosmic wrestling match. The Ancient Supernova Trail. The systematic patterns Voyager 1 detects in cosmic ray intensity and plasma density aren't just random fluctuations, they're actually geological records of our galaxy's violent past, written into the very fabric of space itself. The spacecraft appears to be following trails left behind by supernova explosions that happened millions of years ago, with their shockwaves still carving out pathways through the interstellar medium. These cosmic highways, you could say, channel high-energy particles along preferred routes, and that's what creates the radiation gradients and magnetic field orientations Voyager measures. Some astrophysicists even believe these ancient stellar explosion patterns might influence where new stars form in our part of the galaxy, with magnetic field orientations potentially guiding cosmic material into denser regions that could trigger future star birth. So, the data suggests Voyager isn't just sampling local conditions, it's really giving us a glimpse into the aftermath of cataclysmic events that shape the structure of our entire galactic neighborhood over, well, cosmic timescales. The Eternal Ambassador. While Voyager 1's scientific mission might end within a few years as its power source slowly fades, the spacecraft's journey through eternity is actually just beginning. This small probe will keep silently coasting through the cosmos long after human civilization has either evolved beyond recognition or, disappeared entirely. In about 40,000 years, Voyager will make its closest approach to Gliese 445, a red dwarf star, passing within about 1.6 light-years. It's kind of like a celestial handshake across the vastness of space. The golden record attached to Voyager carries sounds, music, greetings in 55 languages, and 116 images from Earth, all engineered to survive over 1 billion years in the harsh environment of space. This makes Voyager not just a scientific instrument, but possibly the most enduring monument humanity will ever create, carrying the essence of our species into the cosmic deep, long after Earth's continents have shifted beyond recognition. The Real Discovery. The most profound revelation from Voyager 1's journey isn't about discovering aliens or wormholes. It's really about understanding that interstellar space is a dynamic, structured environment all its own, with weather patterns, magnetic topography, and radiation zones. The spacecraft revealed that our solar system exists within a kind of protected oasis, with the sun's heliosphere shielding us from an environment that's way more intense and radiation-filled than anyone realized. The transition to interstellar space isn't simple, it's messy and complex, with magnetic fields that don't line up the way we expected, and plasma waves that show constant activity. The interstellar medium has layers, fronts, and boundaries that shape the invisible architecture of our galaxy. Most importantly, Voyager showed us that we live in a cosmic shelter. Our solar system isn't just our home, it's really our sanctuary in a galactic storm raging beyond our protective bubble, making Earth even more precious than we ever imagined. So there you have it. Voyager 1 didn't just reach the other side, it discovered that the other side is nothing like we expected. Which part surprised you the most about interstellar space? Let me know in the comments below. If you enjoyed learning about humanity's greatest space exploration achievement, make sure to like this video, share it with someone who loves real science as much as you do, and don't forget to subscribe to Sci and Y for more mind-blowing discoveries about our incredible universe. Until next time, keep questioning and keep exploring.